Hi, y'all. So hopefully you have looked at 2011 number 1, that released FRQ that was supposed to be your classwork for Friday, and you've at least attempted these answers on your own. If you've tried and got stuck on a section, that's fine, but if you literally haven't tried at all, go try that and then come back and watch this video. So this question is obviously from 2011. It was one that they used on the AP exam. And we are evaluating sports ball players. So we're evaluating football players to see which one we want to recruit and have on our team. So the first question is asking us, based on the data we have, could we use a normal distribution to describe this data? Well, this is what we talked about on Thursday, assessing whether data is normal or not. And so the things we said was we could look at the graph, we could look at the mean and the median, and then the third thing is we could make sure it fits the 68, 95, 99.7 rule. Well, in this case, we don't have the full data set, so we can't look at a graph. We don't have the median, so we can't compare the mean and the median. So the only thing we can think about is the 68, 95, 99.7 rule, which basically means that our data would have, our maximum should be a little bit bigger than 3 standard deviations above the mean, and our minimum should be a little bit smaller than 3 standard deviations below the mean. And so you can see, excuse me, my calculations there. I've gone through and figured out the mean is 4.6 seconds, so that means 1 standard deviation below the mean would be 4.45 seconds. 2 standard deviations below would be 4.3 seconds, and 3 standard deviations below the mean would be 4.15 seconds. So our problem is the minimum is not less than 3 standard deviations below the mean. It's in between 1 and 2, so it's not even close. So in this case, you would need to go through and say that no, this is not a normal distribution. We could not use a normal distribution to approximate these times. And then you have to say why. So the way I wrote it was, no, it's not reasonable to believe the distribution is approximately normal because we would expect the minimum to be less than 3 standard deviations below the mean, which would be 4.15 seconds. The minimum is 4.40 seconds, which is between 1 and 2 standard deviations below the mean instead. All right, that works. That's a perfectly valid answer. Another way you could approach this is you could try to figure out, okay, what's the z-score for the minimum? And when you calculate that, you end up getting negative 1.33, which basically gives you the same information that I used in my answer. That's between 1 and 2 standard deviations below the mean. It should be less than 3, below 3 standard deviations below the mean. So this is definitely not a normal distribution. So looking at the scoring guide, what they said was you could get an E if you said no, and your explanation was based on the relationship between the mean, the standard deviation, and the minimum. So if you didn't include some reference to all of those in your answer, you weren't going to get full credit. You could get partial credit if you said no, but your explanation left something to be desired. It was real simple or flimsy. And you got an I if it was no, and that's all you wrote. You didn't give any kind of explanation whatsoever. Or you thought it was reasonable, and you could use approximately normal to represent this data. So those are the 2 ways you'd get I. Just saying no isn't enough. You got to give at least a little bit of context. So when in doubt, even if your explanation had been flat out wrong, you would have gotten a P if you had written an explanation versus an I when you didn't even try it. So when in doubt, try, put something. A couple things here. You want to make sure that it, on the notes on there, if you talked about the distribution of running times that you didn't have any information about, they were just going to ignore it. And if you said something that was drastically incorrect, they could lower your answer. Meaning if you read the table wrong or something like that, then they could dock your answer a level. Usually that's not going to happen in something like this. As long as you're not making something up, you're good. All right, so that was part A. Part B is asking us to just go through and find the z-score. So find the z-score and interpret. Pretty straightforward. So plugging that in, we should get 2.4 standard deviations, and it's positive, so that means it's above the mean. So that's what your interpretation needs to say. The amount of weight this player can lift is 2.4 standard deviations above the mean of all other players. Pretty straightforward. For grading, if you did it correctly and you did a interpretation that included direction, you got an E. What they mean by that is saying it was above the mean versus below the mean. They're looking for that as part of your answer. Partially correct if you got one or the other right. Either you did the math right and messed up on your interpretation, or you did your math wrong, but your interpretation was correct based on what you wrote. So you can still get partial credit that way. And then I if they're both wrong. So one thing to note here, let's say you totally freaked out on part A and thought it was a normal distribution. If you calculated a probability from table A, they're not going to take points off here. They consider they've taken their points off in part A. You're not going to, get points docked here. They wouldn't ask if you gave a percentile. They don't care. They're not going to take points off, but it's also not relevant. And you want to make sure, they say in here they're not going to take points off if you don't include context. Always include context. You never know what they're going to get stressed out about. Always include context. Then a couple of things down here that I want to point out that I think is really important. If all you wrote was 2.4 and you didn't give either the z-score formula or the z-score formula with the numbers plugged in, you're not getting full credit. So you've got to give something. Either copy down the formula or write it down with the numbers plugged in. But you've got to show that. So, over here, that's sufficient. How I wrote 370 minus 310 over 25, that would be enough. But if all I wrote is 2.4, I'm not getting an E. I'm getting a P. And if you had, for some reason, decided to sketch a diagram and you didn't write a sentence saying it was above the mean, if you could show it on the diagram, they were going to give you credit. So they were trying to look for ways to give people points on that. All right, now letter C is saying, okay, based on all this information, how are we going to choose between these two players? So we can't do normal distributions, we can't do percentiles, so all we can do is calculate z-scores. And so that's what I have here. I've gone through and calculated the z-scores for both players, for both skills, both the sprinting, how fast they could run the 40-yard dash, and then how much weight they could lift. So again, for work, this is the amount of work that they would need to see. Either the formula or the numbers plugged into the formula, and then your answer. A note here, normally we're used to thinking about z-scores that are below the mean as being bad, meaning they scored lower compared to everybody else. But stop and think for a second. If we're sprinting, if we're running, having a negative z-score is good. That means you're faster than everybody else because it took you less time to run the race. So if we look at the z-scores, there's a significant difference between player A and player B for running. Player A is a whole standard deviation faster than player B. That's a big chunk. But when we look at weightlifting, they're relatively close together. We're at 2.4 and 2.6 standard deviations. That's not that different from each other. So for me, I chose player A because player A was significantly faster than player B, but for weightlifting, they're only a little bit weaker, for lack of a better word. They only can lift a little bit less than player B, so I felt that trade-off was enough. So here's how I wrote it out. I said both players are faster than their peers and stronger than their peers. The difference in z-scores for the amount lifted is very small compared to the difference in z-scores for running speed. I would choose player A because they are entire standard deviation faster than player B, while their weightlifting scores are very close. All right, so you could have made some interesting choices as you go through. So let's look at this one. So to get a E, they wanted you to correctly select player A. They wanted you to use an adjustment of the scale so they can compare for both variables. In general, that means calculate a z-score. That's the easiest way to do it. And then they needed to see you make a comparison for both criteria, for both running and for weightlifting. So you needed to make sure that you said both of those points. If you only did 2 of the 3, you got a partial credit. If you got one of the 3 correct or 0 of the 3 correct, you got an I. So they say in the notes that you didn't have to take it all the way to z-scores if you just talked about the standard deviations. I think it's easier to just go ahead and do the z-scores, quite frankly. But if you wanted to write more, you could compare it just based on standard deviations alone instead of going all the way to the formula. I want to point out that second bullet. It says component 3 is not satisfied by the statement, quote, player A should be selected since the weights lifted are close and the running times are less close, because they want you to actually mention those adjusted scales. They're talking about the z-scores there. So those comparisons. So if you need to make some kind of reference to being one standard deviation faster than the other, the difference in the z-scores, how it was negative 1.2 versus 0.2, and then for weightlifting, how their z-scores were so close together. They need you to include some numbers as part of your answer. Just because it's up here at the top doesn't mean it's like you have to actually reference it within your writing. And they did cut you a little slack if you look at the third bullet. If you talked about z-scores for the running time, and then you just said their weightlifting scores were close, they were going to give you credit. And if you had said back up in part A that the data was normal, if you used probability calculations, if you found the proportions or the percentiles using a table A, they would give you credit here. Again, they're not going to dock you because you did it wrong up in part A. They took their points off there. If you use them here, you would be all right. The last one I want to point out is the miscalculations. So if you just mess up subtracting, so like say for example, you thought that 375 minus 310 was 60 instead of 65. Let's say you just made that arithmetic error. You'd be fine. If, however, when you plugged it into your formula, you just switched the order, or you used the mean for running instead of the mean for weightlifting, then they're going to take credit off. You're going to lose points on that. But if it's just a straight miscalculation, you're okay. Caveat to that is, if all you wrote was the formula, so let's say you wrote this, and you didn't include that part, are they going to know whether your answer was wrong because of a calculator error or because you wrote the formula wrong? They can't tell. So at that point, they take points off. So when in doubt, when you're trying to make sure that you're covering yourself for partial credit, I would write this. Write the formula with the numbers substituted in. That way, it gives you the most opportunity for the graders to give you partial credit if you don't get it right. Hopefully you'll get it right. If you do, it's fine. But if you have some kind of calculator error, like your hand slips on the calculator, if you have that correct formula written with the numbers plugged in, you can still get full credit. Okay, so that is just talking about that 2011 number 1. So now you have a practice FRQ. So Unit 2, Part 2, practice FRQ is due on Tuesday, on test day. You can turn it in online, you can turn it in on paper. And so it is similar to this, but it's not identical. All right, none of these FRQs are ever the same. So for that one, it is dealing with normal calculations. Take a look at it. If you run into any issues, let me know. Bring questions to class on Monday. All right, y'all. I hope you had a good Friday off or semi-off. Enjoyed the day without having to be in an academic classroom. And I will see y'all on Monday. If you have questions this weekend, shoot me an email.